There are signs of a chemical reaction, a chemical change when you make something new. They are solid formation, color change, gas formation, light, and heat changes. So if you combine two clear liquids with each other and you see a solid forming, that is a chemical change. You're making a what we call a precipitate, a solid component of this reaction. If you if you observe a color change, if you see the reaction bubbling, if you burn, let's say, a piece of magnesium and you see that it's emitting light, that is a sign of a chemical reaction. Heat changes. If, let's say, uh, you combine two liquids and something forms, let's say, and then you notice that it's gotten very cold. Sometimes it gets ice cold. In fact, this is how those heat packs and ice packs work. Now, when it comes to balancing chemical equation, this is a skill. We talked about that if we have something like CH4, we're going to eliminate for now the subscripts for the phases so that although they're still important so that we can just focus on balancing. By balancing, we said we cannot start with, let's say, in this case, four hydrogens and then end with two. Where do the other two go? That violates the conservation of mass law. So in this case, what we need to do is we need to balance it. And let me just say one thing from now. Balancing chemical equation does not involve like an equation, does not involve a mathematical formula. It's really like playing with a puzzle. You want to make sure each side is equal in number with the idea that you actually use the least, right? The least uh, in terms of the number, right? The least magnitude number. So least possible number. So in this case, what we can do is we can do the bookkeeping method. So we say, okay, we have C, H, and O. I'm just going to tell you, you really want to play around with these numbers, and it's really like solving a puzzle. So in this case, we have one carbon, four hydrogens, and two oxygens. On the other side, we have one carbon, two hydrogens, and then look here, you have two oxygens, and then you have one here. So that's three. Two oxygen and one from here. That makes it three. So now you want to use the smallest numbers possible to balance the equation. In this case, let's begin with hydrogen. It makes sense. So in this case, we have two hydrogens. We have four. So what we do is we have to use coefficients. So if we put a 2 in front of the hydrogen, in front of H2O, notice now you have 2 times 2, which is 4. 2 times 2. Now, the oxygen is also a different number on this side. So watch what happens. So you still have two oxygens here. And let me actually draw them for you. So CO2 looks like this. We're going to learn how to draw these in the future, but for now, this is going to help you. Here's CH4. And here's O2. Okay, so just verify these numbers. So now, 1, 2, 3, 4 oxygens. So we need to change the number of oxygens on this side. What we do is we put a 2 in front of that, and that makes it a 4. And here you go, it's balanced. You have to practice these, but to be honest with you, I don't stress, I don't emphasize too much on this because again, it's like playing with a puzzle. There are really much more important concepts to focus on. Let's talk about another one where, again, this is based on trial and error. So it may not work from the first time. You have to play around with numbers. So let's look at FE plus O2, and you get Fe2O3. So here's the bookkeeping method. So you have one iron and you have two oxygens on this side. You have two irons and three oxygens on the other side. Okay. So you're inclined to go ahead and balance the iron. We'll do that, but we're gonna have to erase. I'm just letting you know from now. So let's go with trial and error. So you say, yep, this is two and that two. Let's put a two here. And that makes it a two. You're correct. The problem occurs is now when you actually try to balance the oxygen here because you have two and you have three on the other side. You definitely, I wish we can, you definitely cannot multiply by 1.5. So what you do is you actually need to figure out another number that you can actually add in front of this substance to balance the oxygen on the other side. So what we need to do is actually start over. So we're going to erase the one for iron. And instead of starting with iron, we're going to start with oxygen. And let's talk about 2 and 3. The least common multiple between them is 6. So that means I have to multiply this by 2, and I have to multiply this by 3. This becomes a 6, and this becomes a 6. Now, in doing that, you also change the number of iron. So now 2 times 2 is 4. Now, what's the least common multiple between 4 and 1 is 4. Okay. Well, let's talk about now one that has actually, uh, let's say, uh, polyatomic ions in it. So, for example, you may have something like NaNO3, SO4, and you end up with Na2SO4 and CaNO3 2 parentheses. Okay. Now, when doing these kind of problems, yes, you go with the bookkeeping method, but I would suggest that you actually treat the polyatomic ions as one unit. So like this is X, that's X, X, and X. Makes it really easier when you balance these. So in this case, you have sodium, we're going to list them that way, and then nitrate. We're going to list the calcium and the sulfate, and we're going to copy the same thing over on the other side. Now, you may actually balance this by using the individual atoms. That's absolutely fine, but it will take you longer. I'm just going to let you know. So here we have one sodium, one nitrate as one X, one calcium, and one sulfate. On the other side, we have two sodium atoms. Well, let's look at the nitrate. We have two of them. one calcium, and also one sulfate. So we need to balance the sodium and the nitrate. So this is 2 and 2, this is 1 and 1. So what we do is just put a 2 in front of this. And it would be balanced. Now, again, the problems can get, some of them can get very progressively harder, but I won't really ask on really like much harder problems. Let me just end with this. So if we have C3H6 plus O2, that gives you CO2 plus H2O. So again, we list the carbon, the hydrogen, and the oxygen. We have 3, we have 6, and we have 2. C is 1, H is 2, and O is 3. Okay, so let's begin. You may wonder, all right, let's start with the hydrogen. Let's actually multiply this by 3, or even the carbon. You might put a 3 here, whatever you would like to begin with. Again, trial and error is going to be something that you may really have to do. So let's start by balancing the carbon. So in this case, we put a 3. That changes this to a 3. Now, in terms of the hydrogen here, so the oxygen also changed because now you have 3 times 2, which is 6, plus 1, and you have 7. So this is where the problem arises here. So, and then not only this, okay, if we would like to balance the hydrogen, let's go along and actually balance the hydrogen. Let's also put a 3 here. That makes the hydrogen a 6, because 3 times 2 is a 6. Here's where the problem is. When you do the oxygen, you have 3 times 2, which is 6. And then 3, that gives you 9 oxygens. So you can pause the video and really pay attention and see if you understand my point here. The problem is how are you going to balance the oxygen 9 and 2? So you need the least common multiple here. Well, you can't again put a 4.5. So anytime you run into this issue or you have an odd number of oxygens, the answer is clear, is you actually want to double the number, the coefficient in front of carbon. So in this case, what we're going to do now is we're going to just start over. And we're going to erase that. Double this number. So we're going to put a 6 here. And we're going to have to multiply this by 2. So that makes it a 6. But that also changes the number of hydrogens. So in this case, you have 2 times 6, which is 12 hydrogens. Right, so we need now then a 6 in front of this water molecule. So that 6 times 2 is 12. So carbon and hydrogen are balanced. Now let's look at the oxygen. So we have 6 times 2 is 12. And we have 6. So that's 18 on this side. Six times 2 is 12 plus 6 oxygens. So then we have 18 and 2, least common multiple is 9. All right, erase this. And now that's 18.